We're going to discuss TCP Keep Alives. I've gotten several questions about how the process works, and there are basically two Keep Alives. There's a TCP Keep Alive that I'm going to discuss with you, and there's also application Keep Alives. For instance, HTTP, the application that rides on top of TCP, also can use a Keep Alive. So let's first discuss TCP. The way that it works in TCP, if we look here, here's just a few frames, so it's relatively easy to follow. We see in the first frame, the device sends sequence number 6660. It is going to send 96 bytes of data, so 6660 plus 96. We'll say the client there expects an ACK of 6756 for that 96 bytes of data. And we see that ACK of 6756, so we'll say that's the server replying saying, I've received your 96 bytes of data. It has a sequence number of 46314. It's also within that same ACK message going to send 373 bytes. So 6314 plus 373, it expects an ACK of 6687, and we see that ACK of 6687. So everybody's happy, all is good. Now some time's going to go by, and that amount of time that goes by, if we take a look here, is about 30 seconds. We'll just call it 30 seconds there. That the client, nothing has happened, so it's waiting 30 seconds. It's now going to send a probe request to keep this socket circuit session open. So the way that process happens, again, we're still talking sequence numbers, so it's at sequence number, it was at sequence number 756, so it backs up the sequence number to 6755. It sends 1 byte of basically null data, TCP null data. So 6755 plus 1 expects an ACK of 6756. We see the ACK of 6756. That half of the socket is back in sequence. Now you'll notice the server does the same thing. It sends the probe or backs up its sequence number from 6687 to 6686, sends 1 byte of data, expects an ACK of 6687. We get the ACK of 6687. That half of the conversation is again back in sync or in sequence, and then the two can continue on and send data based on sequence numbers where they're at. So now client is back at 6756 plus 96 bytes of data. It expects an ACK from the server 6852. So that is the normal TCP Keep Alive process. HTTP, however, uses a little bit different one. So we can have a Keep Alive for TCP, and we just talked about the application HTTP. So HTTP, for instance, can use Keep Alives, and the Keep Alive is based on seconds. The timeout is based on seconds. So in this case, we see this HTTP session will stay alive for 15 seconds. After that, it will tear it down with a fin, TCP fin. And the max number there is the max number of requests since the connection was created. And when we reach the max number of requests, also it will tear down that connection. So it will only allow, in this case, a maximum of 98 requests. And after that, it will fin or tear down the TCP session. So I hope that's given you a little more insight, information into a couple different Keep Alives, TCP Keep Alives, and HTTP application Keep Alives. Thanks.